Hello everyone. We had lot of sessions for seeing the variety of questions in topic functions. And now one more session on functions problem solving. Let us take the first one. Function f is from R to R, and instead of giving the explicit definition for function, I am given the functional equation, and the equation is fx plus f of x plus 2 equal to root 3 times f of x plus 1 for all x. And f9 is given as 5, and then we have to find sigma r equal to 0 to 100 f at 9 plus 12r and the 4 options. Now, those who are beginners in mathematics here, they may get uncomfortable seeing that sigma notation. I hope that E kind of notation, what you are seeing there at the top, that is called sigma notation. And that sigma notation stands for the summation. Now, those who are new, for them, these 2-3 lines what I speak, that f at 9 plus 12r, and what r is, r starts taking values from 0, 1, 2, 3 like that, and it goes up to 100. So, when r is 1, it would be f at 9 plus 12. When r is 2, it would be f at 9 plus 24, and so on. All such terms are to be added. That sigma notation, that E kind of thing what you are saying, that is for adding the quantities. That stands for the summation. So, when you have long expression and in terms of only sum, that quantity x plus y plus z, like that, if you have a big expression, then we use sigma notation there. So, please do not get perturbed by that sigma notation. What you have to do is, you have to just add functional values. How many values? Starting from r equal to 0 to r equal to 100, means totally 101 terms are to be added. Okay, let us start. When I see that fx plus f at x plus 2 equal to root 3 times f at x plus 1 for all x. Now, this is a functional equation. Now, this is that session where I would give you one more tip, and I would say that competitive examination syllabus does not mention anywhere functional equation, but happily people have been giving questions and students have been answering questions related to functional equations. Suppose you have learned trigonometry, and if I give you some questions on trigonometric equation, will you not answer? I mean, if your basics are clear, you would attempt that question. Same happens with functional equation also. I mean, functional equation otherwise could be a long chapter to learn. I mean, you may have to have at least 3-4 sessions of 3 hours each kind. But without knowing much about functional equation, I have been given here functional equation on the assumption that I should know how to tackle a functional equation. The equation is f of x plus f of x plus 2 equal to root 3 times f of x plus 1, and it is true for all x. That for all x is a nice idea, that you are free to substitute in place of x whatever you want. So, should we replace x by x plus 2? Because, see, we do not have any other information. We have to build information only on this functional equation. So, okay, let us substitute x as x plus 2. And I am taking this advantage because there is written as for all x. Mind you, please, x and x plus 2 both come from the domain of function f. And what is domain? R. So, all are nothing but real values. So, I replace x by x plus 2, and I will get now f of x plus 2 plus f of x plus 4 equal to root 3 times f of x plus 3 for all x. Now, you may think that previously only fx and f of x plus 2 were there, and now with f of x plus 2, now one more has joined, and that is f of x plus 4. Don't get perturbed. We will have to keep on building like this only. And f of x plus 3 also has come. Fine. But when you look at that given functional equation, has any one of you interpreted as that sum of two functional values, that is fx and f of x plus 2, is written as root 3 times some intermediate value? I mean by intermediate that between x and x plus 2, x plus 1 lies. So I am saying f of x plus f of x plus 2 is written as root 3 times value of the function at some intermediate value of x, that is x plus 1. If you interpret like this, then you will understand that f of x plus 2 and f of x plus 4 again is written as root 3 times value of the function at intermediate value. Now add 1 and 2 and you will realize that fx plus 2 times f of x plus 2 plus f of x plus 4 equal to root 3 times, and within bracket f of x plus 1 plus f of x plus 3. Now look at that fx plus 1 and f at x plus 3. Again, can't we write it as root 3 times value of the function at intermediate value? Yes, you can. And it is root 3 into f of x plus 2. Now f of x plus 2 becomes as value of the function at intermediate point. So this leads to 3 times f of x plus 2. Now on the left hand side you have twice of f at x plus 2, and on the right hand side you have 3 times f at x plus 2. So you can simplify it and you will get it as f of x plus f of x plus 4 equal to f of x plus 2. And this is again true for all x. Now, can we move further? We will move by replacing again x by x plus 2. And I will get now f of x plus 2 plus f of x plus 6 equal to f of x plus 4. Now you may think that I am just generating equations one after other. But no, keeping something in mind, I am doing that. Now when I add these two, the third one and fourth one, what will I get? That f of x plus 2 and f of x plus 4 that appears on the left hand side and it also appears on the right hand side. Means those two terms will get cancelled and you will be left with f of x plus f of x plus 6 equal to 0. Now this is again true for all x. Now you must be actually getting irritated. That's how many times we have to replace. Now one more step and then you are at your destination. Don't get perturbed. Now replace x. Now I will not substitute x plus 2. Intelligently I will substitute x plus 6 and I would finish the matter. I would replace x by x plus 6 and that leads to f of x plus 6 plus f of x plus 2 equal to 0 for all x. Best is subtract one from other. And that leads finally to f of x equal to f of x plus 12. Now this is wonderful information. This tells me that function f is a periodic function. And what is its period? One period is 12. And if that is the thing, you try to connect it to the given information now. F of 9 is 5. Now don't you realize that f of 9 and since period is 12, f of 21, they would be equal. Now keep adding 12. Now f of 33 also would be equal to f9. Continue like this and you will realize that you can go up to f of 1209. Every term, f9, f21, they all are equal. And if I substitute in the given information, then I will be adding f9 101 times. And that leads to 101 into f9. f9 value you can substitute. It is given to be 5 and my final answer comes as 505. See, there were many things in this question which were new to you. Functional equation, how to tackle. And if you see the steps involved, from examination point of view, you may think, can question be so lengthy? But if you are expert, I would say, in handling functional equations, then you may do certain part mentally also and you may arrive at the answer. But this was a good exercise to understand functional equation and the sigma notation and also periodic function. Let us move to the next question. And my correct option before I go to second, 505 is the correct answer means option B is the right answer. Okay, let us move to next. And the next question is range of function f where fx is greatest integer of x square minus x plus 1 and x lies between 0 and 2 is. And then 4 options are given and we have to pick up the right answer. We have seen greatest integer of x. We have not yet seen anywhere in previous sessions greatest integer of x square minus x plus 1. Can you see that? Slowly I have raised the level. Previously, we were just dealing with greatest integer of x. And now I'm dealing with greatest integer of x square minus x plus 1. Mind you, please, I'm not doing this journey alone. I'm taking you along. Please pay attention. I have to understand meaning of greatest integer of x square minus x plus 1. Don't you think it's high time that I define first x square minus x plus 1 as gx? Some new name I write there. My gx is x square minus x plus 1. I would study only gx first and then I would attack the problem for fx. Fine. Now when I see x square minus x plus 1, you know how to make perfect square and understand that it is x minus half whole square plus 3 by 4 and it is greater or equal to 3 by 4. So I know minimum of gx is 3 by 4 and that occurs at x equal to half. Fine. And you can take x up to 2, including 2. So let me find out what is value of the function g at x equal to 2. Substitute x equal to 2 and you will get g2 as 3. Now with this information, can I draw graph? Because by now you know how to draw graph of a quadratic expression. I draw graph and I realize that since minimum occurs at x equal to half, I can draw a line parallel, which I have not shown in the figure. If you wish, you can do that. I draw a line parallel to the y-axis through that x equal to half and minimum occurs at x equal to half, so 3 by 4. Graph has to be opening upwards graph and value of the function at x equal to 2 is 3. So the picture, I think, is clear to you that how do I arrive at that graph. Now, since minimum is 3 by 4 of function g, so I understand that greatest integer of gx can be 0 or 1 or 2 or 3. Now, some of you may think that how do I arrive directly at 0 or 1 or 2 or 3? Now, greatest integer of gx. When gx takes values between 3 by 4 and 1, what would be greatest integer? 0. When gx takes values 1 onwards, including 1, but less than 2, what would be its greatest integer? 1. Like that, since g2 is equal to 3, so function has taken that value. So its greatest integer is 3. So I have gathered greatest integer of gx values as 0, 1 and 2 and 3. And what is greatest integer of gx? Is that not same as fx? Yes. So that means fx can take value 0, 1, 2 and 3. And what we mean by range? Range means nothing but set of values of function f. So what is range of the function f? Is it not set containing 0, 1, 2 and 3? Yes, that is the range. So correct answer is nothing but option D. Now, lot of problems by now we have solved. Now, if you actually go through every problem, you will understand sky is the limit. I mean, it is that variety of questions what you see in functions. I mean, it is unbeatable, beyond anyone's imagination. Please keep solving and get that confidence, get that hold on the topic. I will come again with a new thing on the next turn. Till then, stay tuned. Thank you.